The through equal 1269 numbers of ways to stay in the same place after some steps. For this question, you say that you are at index 0 in your array. The array size is array length. So the thing is that you are at index 0 and the maximal position you can reach is array length -1, right? So this is included, and so 0 to, so the length is the array length, right? And plus array length, and it gives us steps. It asks how many different ways you will return position 0 after these steps of operations. The thing is that you can only work in this kind of range, 0 to array length -1. Okay, in this array, you cannot go out of bound. So we need to look at the question careful. It is not this range we cannot -1 we cannot reach. So we just go the person, he is able to stay at a position 0 to array length to -1, and he has 3 options. One is going to right, another is going to left, and the third is stay, right? But stay also use one kind of steps. So it's trying to say how many operations. So intuitively for this question, we can think about the DFS, right? DFS to traverse all of the possible operations, trying to see if it reach original starting point, and if it reach the starting point, then we add to the sum. We have a sum variable or result variable. But when we calculate, we find if we use DFS, we may, for example, add a position here, right? And every time, possibly to have, for example, remain steps, right? At the beginning, this remains steps, and for every state, it has a position and the remains. So for the DFS, these 2 variables decide what kind of state this person is. So it's possible this kind of position and the remains being calculated in the previous round. So what we're thinking about is that we can use memo, possibly use 2-dimensional array, because this kind of state that one is position, right, and another is remaining steps to store this kind of state, so that if we already calculate how many what position he is and how many remaining steps he left, we don't need to calculate again. So we can write this question in DFS and memorizations use a memo. So let's begin to write code for this. And we need to mod, right, because the number is large. We know this person, he cannot move out of the array length, right? So we can have the memorization of array length and steps +1, right? We can get this range even smaller because he can maximally go to steps, right? So the farthest position he can reach is steps. So we can have minimal, right? Minimal steps and array length. And yeah, we are step plus one, right? Because array length this is the n, right? So the memorization size, we can have a max variable, right? We just have this max. So let's begin to write code. We'll say this max will be the person, the farthest position he can reach is max dot min steps in the array length minus one, right? So we are going to use a memo. Memo. We say this memo. We need two dimensions. One is its position, right? So we'll say max plus one, right? And steps, right? So he has steps minus one. Okay. At the beginning, we can set this memo to be some value, for example, negative one. Okay. Arrays, field, memo. Let's do this. So int array, memo, arrays, field, array, minus one. Okay. So what we need is DFS, and we'll say at the beginning he's at position 0. He has the steps, remaining, right? And and also he cannot go out of the array length. Do we need this variable? Array length. Do we need this? Okay. We may not need this one as well, right? And we just return, return. So we have private int DFS will pass in current position into remains, and this one as number. So we'll say if memo current remain current equal to -1, just return this value, right? Return memo current remain. So we'll have some kind of initial value if remain equals to 0, right? Let's say if the current position is at 0, we'll return 1. Otherwise, means this is the one possible solutions, right? Otherwise, we'll return 0 because this is not possible. Okay, so let's have a result, right? Result equals to 0. we needed to have direction array. So we'll have a private final static into PIR because he can move left, you can say, can move to the right, yeah. And we also need to have the mod final static MLP. This one we can basically like this, right? Equals 1, 0, 0, 0, 0, 0, 0, 7, okay. So we'll have for if I equals 0, that's smaller than 3, I plus plus, right? So we have 3 possible choices. So let's say in new position equals current plus dir. Okay. Well, we still need its length, array length, because it's made out of bond. So let's have the array length. Because the maximum steps may be greater than this in array length. So for this new position, if new position is smaller than 0 or this new position greater equal to array length, right? That is out of bound. We need to continue. Otherwise, our result will plus equal to here we need to mod, right? So result equals result plus DFS new position and remains -1, right? We have used one more step array length and the memo, and we need to mod by MOD, right? And in the end, we need to store this one into the memo and return result. Memo current remain equals result and return result. It. Anything else? If remains remain, let's call this one remain. If any three out of 4 lengths true. Here that seems that we should use a steps plus 1, right? I don't know why I put this one as -1 here. Yeah. For the time complexity, as we know, the DFS plus memorization is the same as dynamical programming. That's another form of dynamical programming. But for this question, use the DFS and memorization. It's more straightforward. But the dynamic programming, we know there is a max plus one for loop and a steps plus one for loop, right? So there are two for loops. So I think that will be steps multiplied by array length.